Hey mate, hope you're well. I just wanted to give you guys the update on the accuracy testing of the Eureka Stockade 223. So how this is going to go is I'm first going to talk about how we planned on executing the test, what we wanted to achieve in the test and what we wanted to test for, then the actual equipment that we used, and then I'll show you the test results. And we had a little bit of a surprise towards the very, very end, which, yeah, I'll get into towards the end anyway, and then a quick summary of where we're going from here. So in terms of what we plan to test, so we wanted to basically ensure that the firearm is sufficiently accurate for the task at hand. Now, I need you to understand that this is not a precision bolt action rifle that is going to be used to shoot 1,000 meters or 600-700 meters and make tiny groups, right? That's not the purpose. The purpose of this firearm is to dispatch varmint and use it as a hunting rifle. Now, keep that in mind, all right, once we get to the test results and why. So then how we're doing it, the other thing we wanted to test for is ensure that the barrel and the barrel extension and the chambering is near perfect, so that to exclude that as a part and finding any errors in the design of the firearm if we are not happy with the accuracy. So as I mentioned, last week we did an accuracy test, and to be honest, the groups were all over the shop. We had a point of impact shift from one group to the next, even though we were using the same shooter, the same ammunition. We had the random flyers that would open up the groups. The overall group size went from the first, let's say the first group of 5 was like 2 MOA, the next one would be 1 MOA, the next one was 2.5 MOA. So it was clear that something wasn't right. So we sort of worked our way through the firearm and tried if we left anything untightened. Come to find out on the very end, we found out it was the absolute basic. The scope has rattled loose and the scope wasn't tied down at all, and we saw the scratch marks on the scope. And so when we then looked at the scope, and I'll show you a screenshot, you can see the scope basically moved all the way forward towards the rings, and we had it centered in the beginning. So that wasted a day and a fair bit of ammunition, and we couldn't really come to a conclusive result. So we couldn't say, hey, the gun shoots great or not, because it was like all over the shop. So we had to redo it. So this time around, obviously, we checked all the basics, and we went for it and conducted the test. Now, we conducted the test in a manner that is more towards what we're going to see in real life. How are you guys going to use it? Okay, so we did 2 groups of 5 in quick succession. So let me explain it this way. If I wanted to show you that this rifle shoots 1 MOA or sub MOA, I can make the test the way to show it, right? And I can just shoot that many groups that eventually, statistically, a 3-round group will give me half an MOA, and then that's what we're going to show, and I'm going to show you that and say, hey, the gun is half of an MOA gun. Well, she isn't, and she's never meant to. And so what we've done instead is rather show the real deal, right? We did 2 groups of 5 in quick succession. Now, what that means is that the first round going through the barrel and the last round will have heated, between that, the barrel would have heated quite substantially or quite a bit. So it's not shooting for accuracy in that regard, right? So if we wanted to fudge the test, we would do 1 round, wait a while, do another round, wait a while, and do a 3rd one, and we would just repeat that many times that we're gonna show eventually a half MOA group and then call it a day. So that's not what we're doing. We're doing 5 rounds, quick succession, then we wait a little bit to cool the barrel back down, and then we did another 5-round quick succession with the same ammunition. And then we move on to the next set of ammunition. And then we work our way through the entire day, basically. Now, we have only scrubbed the barrel once during the entire test. We have, I was the shooter the entire time. However, I noticed because we had actually an ex-sniper with us there, and one of the groups I'll show you, basically I shot a perfect letter. Though the group is basically a perfect string, and he told me I was putting too much pressure on the buttstock up top, and that causes that. So it was interesting. It was a little bit. I mean, obviously there's an impact from the shooter, for myself quite a bit, but overall very happy. Now then we were looking for a point of impact shift. So let's say it's top right corner. If it's always top right corner, great. But if it's top right corner and then suddenly somewhere in the middle, we have an impact shift between the two groups, and that would actually be a real problem. The next thing we're looking for is groups opening up and closing. So when you shoot 5-shot groups with the same ammunition, you expect a very similar size of group. So what we don't want to see is what we saw in the first test, which is a 1 MOA group and then a 2.5 MOA group. That doesn't work, right? It needs to be somewhere close. Let's say 1.8 and 2.2. That would be acceptable because probably the barrel was warmer, didn't wait too long, or any other effect, right? But they're not really vastly apart from each other. So we did that. And we're going to look for that in the test. And then obviously anything shooter related, like a perfect line or in any direction. But you'll see the groups are pretty good. So we haven't seen any, well, we've seen what I've just described earlier about shooting the letter. To set a baseline, what we've done is we did what's called a letter test. So we loaded ammunition, we loaded it with 22 grains, and then we increased by 1 grain. So we did a group of 3, and then again a group of 3 with 1 grain more, and so on. We started with 22 grains, then we moved up to 23, 24, 25, and 26. And as you can see on the screen, we had a 0.25 group, MOA group, which is the first and only group of that size that we shot in the entire testing. I mean, we've shot 500 rounds through that gun, right? And then you can clearly see, she really liked that, to be honest. And then you can clearly see how the group starts to really quickly open up and continue to open up. Unfortunately, we didn't go any further because we would have potentially seen the group come and close up again as the rounds get hotter and hotter, because you would have hit the next node that closes up the group. So for the people that are not into reloading and harmonics in the firearm, basically think of it the vibration. If the round leaves the barrel always at the same spot where the barrel stands still in that very, very, very moment when the vibration goes through the barrel from the explosion in the chamber, then you get really small groups. But if the barrel whips and doesn't whip to exact the same spot because the timing isn't right, then you sort of get groups opening up. It's not the best description, but basically think of it like waves. And if you hit a node where the barrel stands still, you get small groups. And if you're outside of that node, the barrel isn't in the same position at the same time when the bullet leaves the barrel. And so as you increase the powder charge, you increase the size, and eventually it'll decrease again, get to a node where it's the perfect timing, and then it opens up again. So you want to find that node, and that's what reloaders work towards, finding that node and then perfectioning it and make the group as small as possible and consistent. So anyway, long story short, 0.25 MOA, our best result so far with a 22 grain charge. The equipment we used, we just used a standard rest with a sandbag underneath the buttstock, which worked quite well. and we shot at 94 meters. But the system we use is called a long shot target camera. Absolutely epic. I mean, I used it now for the first time thoroughly during this test, and heck, I'm not going back. So basically, what this is you put a camera, the long shot camera, about probably what is that, 4 or 5 meters off the target, a little bit to the side, so you don't shoot your own camera. Though they come with a bulletproof warranty, so if you shoot it, you get a new one. And so then we Wi-Fi that camera, Wi-Fi's to an iPad or a tablet, and in the app, we can zoom in onto the target, and then we can mark each shot. And because we told the app how big the target is, the actual target, like we give it a measurement between the inch boxes, we just click on an inch box and say that's an inch, it can calculate for us the group size. So not only can we mark it, and which means we can mark it in different colors, which means we can shoot on the same target with shooting multiple groups, and then we just mark them in different colors so we know exactly which shot is which shot. But also within each color, it will calculate the size. And so as you see here, we started shooting and then marking the shots, and then you can see how it calculates the distance. The group size. Now, because we told it how far it is, 94 meters, it will then work out what a real MOA is. So you might see that the inches don't match the MOA. That's because it's 94 meters, not 91 meters. So focus on the MOA label. That's the one that we really care about, because that's the proper definition, right?
All right, guys, let's get into the results. Now, all the results are sorted by size, meaning we're starting with the smallest size and then we're making our way to the ammunition that shot the biggest sizes. Starting out with the letter test, so that was Rick's reloads that we mentioned earlier, 0.24 or 0.25 MOA. That can't really measure that exact, but with the 22 grain charge, that was basically the result. Then we have 1.19 MOAs with a 23 grain, 1.39 MOA with a 24, and 1.63 MOA with a 25. And as I said, the groups are getting bigger, and then later they might become smaller again. Now, the next best one was the Hornady Super Performance Varmint 53 grain VMAX. The first group I shot was 2.36 MOA, but that was the one that was in a perfect line. The next 5-shot group was 0.95. And as you can see on the picture, basically, if it wasn't for me, it most certainly would have been a 1 MOA or sub 1 MOA group. So we're pretty happy with that. That's probably the best off-the-shelf ammunition that we shot through the 1-in-8 twist rate 20-inch barrel that we used for this test. Now, we should use the same barrel across all of the ammunitions that I'm going to talk to you about now. Now, the next best one was, funnily enough, the Frontier 55 grain Spire points with a 1.43 MOA and a 1.15 MOA group. Followed by that was the Hornady Super Performance Match 75 grain boat tail hollow point with 1.84 and 1.51. Following that, we got the Hornady 55 grain VMAX with 2.08 MOA and 1.74 MOA. Hornady 55 grain soft point came in with 2.16 MOA and 1.85 MOA. The Winchester Varmint X 55 grain polymer tip came in at 2.58 and 1.59 MOA. Now, obviously, PPU is in the mix with the 55 grain soft point, and that is a 2.65 and a 2.12. Winchester power point 64 grain. Holy crap. That just escalated quickly to 4.06 and 5.44 MOA. So she didn't like those, not at all. So basically, what I noticed typing all this up is that every single group that I shot first with the same ammunition was larger than the second time I shot 5 rounds. So I don't know what it was. Maybe it was a break in between, or the barrel warmed up a little bit more. But basically, with the exception of the Winchester PowerPoint on the end, every single group is a solid 0.3 to 0.5, even to 1 MOA better, which I find quite interesting. So I'll probably blame myself for that one. But look, overall, the summary is, does the gun shoot 1 MOA with reloads or better? Heck yeah. Can it shoot 1 MOA or close to that with off-the-shelf ammunition? Yes, it absolutely can. I suspect that the 16 point, this is my working assumption, that the 16.5 MOA bull barrel is probably going to be even more accurate than this one. But time will tell. Now, on that topic with the barrels, so what we have decided is that we will only offer the match grade barrels, or the bull barrels, heavy barrels, however. However, they're not heavy. This is the whole thing. So the standard 20-inch barrel weighs more than the match grade barrel because the fluting takes out so much weight that it's actually lighter. So we then sat down and basically went, well, with the 16.5, it's pretty much the same as well, or it's going to be neglectable in terms of the difference in weight. So we sat down and we went, well, it's the same weight or lighter, and it's more accurate. So why would you ever want to shoot a standard? Now, we took a chance here. We hope you appreciate it, but we'll only offer the heavy barrels. We will offer them in 1 in 12 and in 1 in 8 twist rate. So that's totally up to you. And the sizes will be 20-inch or 16.5-inch. So yeah, totally up to you. But we think the match grade barrel is just the better barrel. Sure, it costs us a tiny touch more or a bit more, but I think it's going to make the gun overall more accurate and just a better gun. And hey, if the barrel is lighter, why wouldn't you? Really? Anyway, hope you appreciate that change. And I hope you appreciate the accuracy of the rifle for what it is, because, you know, again, it's not a high precision bolt action rifle. It's a gas operated hunting rifle, and for that it certainly does the job. Like anything is dead within 300 meters without a problem. So anyway, leave that with you. Now, one more thing that happened on the end. So in the last 5 rounds that we were shooting, our firing pin broke. So the firing pin wasn't hardened, and purposefully not hardened, because we wanted to see where the stresses are going to be on the firing pin, and eventually the firing pin gave in, and that was it for the day. But luckily it was, number one, after about 600 rounds. Number two, it was on the last 5 rounds of the day, so it didn't really set us back at all. It's just one type of ammunition that we didn't get to finish off. So please comment below and give us some feedback and what you guys think. And if yeah, are you guys happy? Well, what's going on? What are you thinking? Now, I do want to say one more thing. We've received several emails from actually a few gunsmiths talking about that it is a bad idea to mount the forend to the gas block because of 2 reasons, actually 3 reasons. Number one, they predict that we will have vibration issues or inconsistency, of the group size based on the vibration going from the gas block into the more so from the handguard into the gas block, therefore into the barrel. So therefore the barrel isn't free floating, and therefore the results are not going to be as good. That's one point. The other point is that the gas block heats up, and if it's connected to the forend will heat up faster or more severe than it would if there was air in between, because then the air has to heat up and then the air heats the aluminium rather than the steel aluminium. So, and then the last part is the gas block heats up and heats the aluminium forend, and the aluminium forend, because of the different timing in heating, as in the material heats up differently between steel and aluminium, obviously. What it would mean is that what's assumed is that the barrel will be moved just that little bit by the forend, which then will cause a point of impact change. Now, we're aware of it. We really appreciate the feedback, and we will certainly test each individual one and see if they have impact. We have, in the meantime, also considered a redesign of the gas block in order to make it free floating. The missing part for us to execute that at the moment is that we have to be comfortable that the connection of the forend onto the adapter piece that sits in the upper receiver is solid enough that the forend does not move up and down, and it's just sturdy in there. So we have at the moment 4 or 5 fixing screws anyway in the forend to hold it. So it should by itself hold, but we don't really know until we actually have the forend, which hopefully, fingers crossed, we have in a couple of weeks, the samples, to then test how much pressure can we put on the forend before it actually moves, and does it move at all, and does it impact at all, or can we just have a, basically, we call it a semi-free floating, because the gas system will always be connected. There is no way around that, but obviously having something screwed into it can be perceived as not free floating, and then it could have impacts. Now, again, thanks for the feedback. Great pointers. We certainly will look into it, and we make sure that it won't have an impact on the accuracy. And yeah, so stay tuned. There'll be more testing. On another good news story is that we have placed the barrel order, so we expect the barrels to arrive in about 3 months. And then we should be going into full production. So at the moment, looking at end of April, yeah, we're looking at full production in June at this point, end of May, June. And we should, at this very moment, punch through all orders within about 3 months. So if you're still on the edge, jump in now, secure your spot in the line. And yeah, again, thanks for everybody who has ordered since the last video. Much appreciated. And thanks again to everybody for the great comments. It really, really encourages us to, smash this out for you guys. Oh, and for us, I want one. Heck yeah. Anyway, gentlemen, thank you very much for your time. Much appreciated. Again, it's a long video, but I hope the information was worthwhile. Cheers. Have a great night. Bye.